All right, for this video, we're going to talk about arithmetic sequences. This is the last thing we're going to talk about in this unit, and then we'll start our functions review. I'll let you work on that for 2 days. You'll take your test for 2 days, okay? You'll take your test Thursday and Friday. Let's go ahead and get started so we can finish up this unit. So the standard we want to discuss is defining sequences as functions, and we'll talk about that toward the end, including recursive and what we call explicit, guys. So what we want to do is we want to write explicit and recursive formulas for arithmetic sequences. Some people say arithmetic. It's the same thing. I noticed that this has geometry or geometric sequences in it, but we're not going to focus on geometric until second semester. So for right now, we want to write explicit and recursive formulas for arithmetic sequences and connect them to linear functions. So that's our goal today, okay? And we're going to be able to evaluate some of these and write rules for them. That rule is if you hear me say the word formula, rule, or process, you can just refer to an equation. Most of the time I'm talking about writing an equation, okay? And that's it. All right, so let's get started. A sequence is a list of what we call terms or numbers in a particular order, okay? You can put numbers there if you want to. A list of terms in a particular order. When I say terms, I'm talking about numbers. For example, 2, 4, 6, 8, they're in a particular order. 1, 3, 9, 27, they're in a particular order. Here I'm adding 2. Here I'm multiplying by 3. 1 times 3. 3 times 3 is 9. 9 times 3 is 27. But a sequence is just when you have things or numbers set in particular order, okay? But we call these things terms, these numbers terms. An infinite sequence is a sequence that goes on forever, hence the word infinite. And you'll see the ellipses at the end. 1, 3, 5, 7, 9, and then you got the ellipses indicating and so on, which means it goes on forever, okay? A finite sequence, well, if it's not infinite, it's finite, is a sequence that does not go on forever. So sometimes you'll see sequences, but they just stop. And let me put an example. This is a sequence, but you don't see the ellipses, so it doesn't go on forever. It stops after the 4th term. If you look at number 4, it says an arithmetic or arithmetic sequence is a sequence created by blank or blank the same number to get the next term. Well, it's a sequence created by adding or subtracting the same number to get the next term. You got some constant. We call this, whatever we add or subtract, we call it a common. There it is next. Sorry, guys. It's called a common difference. So number 5, common difference, we're going to denote it D. So the variable we're going to be using for common difference is D. That's that number we're constantly adding or subtracting to get the next term. But instead of me saying common difference all the time, a lot of times you just hear me say D for the difference. So the common difference is the number that is added or subtracted to get the next term in the sequence. So let me give you an example. How do I get from 5 to 10, from 10 to 15, from 15 to 20? Well, all we're doing is adding 5. So here the common difference equals 5. Or you just hear me say or watch me write D equals to 5. Your difference can be negative because you're subtracting. Basically, when it says adding or subtracting, you can add, think of it as adding a positive, and think of subtracting as adding a negative. Adding a negative is like subtraction. So here, you can think of this as subtracting 2. 9 minus 7 is 2, or saying 9 plus negative 2. It's the same thing. 7 minus 2 is 5, or I can say 7 plus negative 2 is also 5. 5 minus 2 is 3, or I could say 3 plus negative 2 is 1. So the common difference here, I'm just going to put D equals, it's negative 1. We read it as negative 1. Although, like, we're subtracting 1, we read it as negative 1 because it's like adding a negative, okay? All right, determine whether the sequences are arithmetic sequences, and if so, we're going to identify the common difference. So in order to be arithmetic, we have to be adding or subtracting the same number to get the next term. Well, you add 4 to 1 to get to 5, 5 to 4 to get to 9, 9 to 4 to get to 13. So this is arithmetic, and I'm going to put D equals to 4. On number 2, 1 plus 2 is 2, 3 plus 2 is 5, 5 plus 2 is 7. No, this is not arithmetic. I don't worry about a common difference. 5 plus 3 is 8. Let me change this. 5 plus 2 is 7, but we didn't get 7, we got 8. So this was actually 5 plus 3. So the difference changed. So it's not arithmetic. Here, 8 minus 2 is 6. 6 minus 2 is 4. 4 minus 2 is 2. Yes, this is arithmetic. And D is negative 2. You can look at it as adding negative 2. Negative 5 minus 3 is negative 8. Negative 8 minus 3 is negative 11. Negative 11 minus 3 is negative 14. Yes, this is arithmetic, and D is negative 3. You pause the video and try 5 and 6. All right, this is what you should have gotten. 5 plus 5, that's 5, guys. Hold on. 5 plus 5 is 10. And 10 plus 10 is 20. That is definitely not arithmetic. It's geometric, it's multiplication. 7 minus 1 is 6. 6 minus 1 is 5. 5 minus 1 is 4. Yes, this is arithmetic, and D equals negative 1. Right, let's move on. Find the next 3 terms in an arithmetic sequence. I have a habit of saying arithmetic, guys. Doesn't matter how you pronounce it, though. And state the common difference again. But this time, I'm not just trying to figure out whether it's arithmetic or not. I'm telling you it is arithmetic. So I'm going to find that common difference and state the next 3 terms. 8 minus 2 is 6. 2 minus 2 is negative 4. Negative 4 minus 6 is negative 10. Negative 10 minus 6 is negative 16. Negative 16 minus 6 is negative 22. Negative 22 minus 6 is negative 28. So the next 3 terms are negative 16, negative 22, and negative 28. And the common difference is negative 6. 54 plus what gives us 63? plus 9. 63 plus 9 is 72. 72 plus 9 is 81. Your common difference is 9. If I add 9 to 81, I get 90. Add 9 to 90, I get 99. Add 9 to 99, I get 108. Those are the next three terms. All right. What am I doing on 108 to get 90? So I'm taking away 18. 90 minus 18 is 72. 72 minus 18 is 54. 54 minus 18 is 36. So the common difference is negative 18. Excuse me. I didn't mean to put that. 36 minus 18 is 18. That's the next term. 18 minus 18 is 0. 0 minus 18 is negative 18. Those are the next three terms. What are you doing on number 4 to get from 3.5 to 4.9? If you don't know can't figure out what you're doing sometimes, all you do is take two consecutive terms. That means one behind another and subtract. And it will give you your common difference. Your common difference is 1.4. I knew it was 1.4. Most of you probably did too. But I'm telling you, if you don't, just take two consecutive terms and subtract them. So I could have taken these two and subtracted. Just as long as they're one behind another, you can take two consecutive ones and subtract them. All right, so I'm going to add 1.4 to 7.7, and I get 9.1. Add 9.1 and 9.1 and 1.4, I get 10.5. Then I get 11.9. All I'm doing is adding 1.4. Right on number 5. To get from 1/3 to 2/3, I'm just adding 1/3. To get from 2/3 to 1, I'm adding 1/3. 1/3 plus 1/3 is 2/3. 2/3 plus 1/3 is 3/3 of 1. So the common difference, the common difference is 1/3. So if you add 1/3 to 4/3, you get 5/3. Or you could write 1 and 2/3. Here you get 6/3, which is just 2. And then you get 7/3, which is simply 2 and 1/3. I don't care if you write them as improper fractions or you write them as mixed numbers. It doesn't matter. All right, let's take a look at number 6. I'm going from -8 to -2, -2 to 4, 4 to 10. So this is going up. I'm adding 6. -2 plus 6 is 4. 4 plus 6 is 10. 10 plus 6 is 16. I'm going to write D equals 6. 16 plus 6 is 22. And 22 plus 6 is 28. All right, this whole process is what we call recursion. Recursion is choosing a starting term, some number to start off with for a sequence, and then repeatedly applying the same process to each term to arrive at the following term. So here on this one, we repeatedly added 6. We might have started off with -8, but we added 6. Or we might have started off with -2, but we added 6. Here I repeatedly added 1/3. Here I repeatedly added 1.4. Here I repeatedly subtracted -18. So that process of repeatedly adding to get to the next sequence number, term, or number in the sequence is called recursion, okay? So this all of 1 through 6 was recursion because all we did to get to the next three terms was just add to the previous term. when I say add, I mean like add a positive or add a negative. Basically, add or subtract. Okay. But there are actually two ways you can get terms in a sequence, arithmetic sequence. One is called using the recursive formula from recursion, and the other one is called the explicit formula. So I'm going to tie those together, okay, on this page. It says there are two formulas that help arrive at terms in an arithmetic sequence. Consider the following arithmetic sequence. I'm here, guys. 2, 6, 10, 14. And let's find the sixth term. To find the sixth term, well, we know that D is 4. That's what you've learned, this recursion process. Again, finding the term this way is called the recursion process or recursive rule, guys. It's a useful way for finding and underlying this smaller terms in a sequence. And we can summarize this rule using the formula a sub n equals a sub n minus 1, sub meaning sub below, sub, a sub n. A sub n equals to a sub n minus 1 plus d. We all know that d represents the common difference. So I'm going to fill that in. D is your common difference. And then n is the term you're looking for. So in this particular case, we're looking for the sixth term. So let's find the sixth term, guys. So n would be 6. I'm going to go on down here, okay? All right. Let me write that 2, 6. Okay, I'm going to write that down. 2, 6, 10, 14. I'm going to make this thicker because I don't like it being so thin. That looks better. 2, 6, 10, 14. And we want to find the sixth term. Well, what I want you to do is write a rule for the sequence and then find the sixth term. So there are two things we're going to do. We're going to write a rule. You write a rule by using your equation. A sub n equals to a sub n minus 1 plus the common difference, which we're calling it's d. So the term we want to find is the sixth term. So n is equal to 6 and d will be equal to, what are we adding each time? 4. So all I'm going to do is replace n with 6. So the rule is a sub 6 equals a sub 5 plus 4. All this means is the sixth term is equal to the fifth term plus 4 more. That's all that means. Okay, this is the rule. The rule to find the sixth term is to take the fifth term and add 4. That's your rule. That's what you do. And this means the sixth term. And this means the fifth term. So the rule to find the sixth term in this sequence, again, is to take the fifth term and add 4. So what we're going to do is find the sixth term by applying the rule. So we're going to take the fifth term. So the fifth term is 18. So a sub 6 equals to, and I got 18 because that's the first term, second, third, fourth. So the fifth term would be 18. So we're going to take the fifth term of 18 and add 4. So a sub 6 is equal to 22. In other words, the sixth term is 22. So I've answered both of those bullets. And that's what you do. So it's going to ask you in your standard. It's going to cover in your standard. Writing, you got to write these guys, explicit and recursive formulas. Okay? So you're going to have to write this rule. You need to remember this for recursion. You got to remember that formula so that you can write this rule, okay? You have to be able to write these things and know how to read them. And then know how to evaluate them, okay? Your fifth term is 18, so replace 18, 8 to the fifth, excuse me. Since your fifth term is 18, you're going to replace 8 to the fifth with 18 and add 4 to it. It gives you your sixth term. All right, now let's talk about the explicit formula. Again, the recursive formula is very good if you're just going to be finding smaller terms, guys. Okay? It's the only reason I would use it. Now, go to where it has explicit formula. It says, still considering this arithmetic sequence 2, 6, 10, 14. Now, what is the 214th term? The sixth term is very different from the 214th. Anybody in this room want to keep adding until we get to the 213th term to add 4? Anybody? I would. Okay. So the explicit formula is going to come in handy when you got like larger terms. The recursive process would be a little time consuming if we kept going until we found a 213th term to add 4. So there's a faster way to find the larger terms. So underline this. That there's a faster way to find larger terms called the explicit rule or the explicit formula. So we're going to take a look at the formula below. This is the explicit formula. You got to please try to remember this. So it's a sub n equals to a sub 1 plus n minus 1 times d. Okay, so like here you don't need to know the 213th term to get the 214th term. Over here, I would need to know the 213th term. And then I'm going to write it like this. So over here, I would need to go to find the 214th term. I would need to find the 213th term and add 4. That means I got to, in this right here, I got to go all the way up to the 213th term. No. Okay. But here, I got to know the 213th term on the recursive formula. Here, I don't have to know on the explicit formula. I don't have to know the 213th term. I just need to know that n is the term I'm looking for. Which is, in this case, 214. The common difference is still 4. It's the same sequence. And a sub 1, well, if a sub 6 stood for the sixth term, and a sub 5 stood for the fifth term, then a sub 1 would stand for the first term. So what we want to do is write a rule that will help us find the 214th term really easy. So we're going to write a formula or a rule. Use a formula, write a rule for the sequence. Okay. Take the time. Hold on, guys. Okay. So the formula is a sub n equals to a sub 1, the first term, plus n minus 1 times the common difference. So n, in this particular case, what term do we want? The 214th term. What is D? 4. What was the first term in this sequence? A sub 1 equals, I think it's 2. See, the very first term was 2. So A sub 1 is 2, okay? And I'm going to write it right here so I don't keep looking back. The very first term is 2, so A sub 1 is 2. So now all I'll do is plug in, change n to 214. That's the term I want. The first term, A sub 1 is 2. Plus, I want the 214th term again, minus 1, times D, where D is 4. Oh, excuse me. Okay, guys, don't do this when you're writing a rule. Okay, don't only do that, plug in a 214 when you're writing the, when you're finding the 214th term. Right now, I just want to find the rule, so I want to leave n, okay? That's my fault. I still want to replace A sub 1 with 2 and replace D with 4. So when you write the rule, leave n alone. When you write the rule, don't change n, because a rule is an equation. So to have an equation, we need a variable, guys. Gotta have a variable in there. Okay, my variable that I'm going to leave is n. So you got A sub n equals to 2. And then this is just using the distributive property backwards. 4 times n is 4n. And then 4 times negative 1 is negative 4. I simplify mine. Some people stop right here. But I simplify mine by combining like terms. So I ended with 4n minus 2 as my rule or my equation, okay? I use this one because I simplify. But again, if you're going to write a rule and a rule is an equation, leave the form and leave the n, leave the variable. Don't change it like I was about to do. All right, now when you find the 214th term, all you're going to do is write your rule back down and replace n with 214. Now is when you replace n with 214. So the 214th term is 4. It's going to be equal to 2. 4 times 214 minus 2. 214 times 4 equals 856 minus 2. So the 214th term is 854. So I've written the rule and I found the 214th term. And I didn't have to go all the way to the 213th term and add 4. So I didn't have to do the recursive process because we have something called the explicit rule. Okay. All right, you're going to pause the video and you're going to try using the recursive rule. And you're going to find the recursive rule for that sequence at the top. And then find the 7th term. And then you're going to write an explicit rule for that same sequence, but find the 84th term for me, okay? I'll go ahead for 30 minutes. All right, this is what you should have. All right, so the recursive rule, I need the formula. A sub n equals to A sub n minus 1 plus D. So again, I'm going to keep n. In this particular case, and we changed it in up here. Oh, yeah, I need to change it here. Change n here because for your recursive rule, you need the previous term. So I need to know what that previous term is. And then plus 4, okay? All right, so you know what? For my test, let's just keep it. Let's just keep it. All right, yeah, let's do that. Because what happened is you get confused. You'll keep it on one and not on the other one. So let's just keep it on this one. It's 8n minus 1 plus, here the common difference is 3. So D equals to 3. So let's just keep it like this. So I'm going to go back and fix something, okay, guys? Erase this. We're going to keep n on both of them so we don't get confused. So your rule that I want you to write on this one is a sub n equals to a sub n minus 1 plus 4. And I want you to stop right here. And then when you get ready to find the sixth term, then replace n. We're going to keep it consistent. So we're going to have a sub n equals to a sub n minus 1. Take your rule. You're going to replace, let me erase all this. That's my fault. You're going to replace n with 6. And the fifth term is 18, and 18 plus 4 is 22. Yeah, I think it's better to go this route where you keep n when you're writing the rule. We're going to keep n on both of these. Recursion and the explicit formula, okay? Just keep n and only replace n when you get ready to find the term. That way we're doing the same thing on both. So I'm going to stop right here. And then I'm going to find the seventh term. So I'm going to take my rule. I'm going to change n to 7. So a sub 7, if I can get it to right, a sub 7 equals to a sub 7 minus 1 plus 3, which means the seventh term is equal to the sixth term plus 3. Well, now I just got to find the sixth term and plug it in. Well, that's the first term, second, third, fourth, add 3, we get 16. That's the fifth. Add 3, we get 19. That's the sixth. 1, 2, 3, 4, 5, 6. So the sixth term is 19. 19 plus 3 is 22. So the seventh term is 22. I'll be honest. Basically, I see no point in writing a rule for the recursive formula because I can easily list out to the 22nd term without writing a rule. I see no point in it. Guys, I'm fine if you just use the explicit process on my test or the recursive process without writing a formula, but the standard says you're supposed to be able to write the formula for both of them, so I got to teach it. All right, this one says write the explicit rule for the same sequence. I'm going to write the sequence down again. 4, 7, 10, 13, blah, blah, blah. Well, and so on, guys. It's not blah, blah, blah. All right, so I'm going to write the rule first. A sub n equals to a sub 1 plus n minus 1 times d. You can put the d on the other side of n minus 1 if it looks better to you. It looks better to me. All right, I'm going to keep n. Replace a sub 1 with the first term. That's a sub 1. The common difference is 3. And then just simplify. Again, some people stop right here. I simplify mine. It's going to be 3n minus 3, and then I combine like terms. 4 minus 3 is 1. So this is the rule that I write. All right. And then you're going to find the 84th term by using your rule. So you're going to find a sub 84. Change n to 84. We're going to multiply 3 times 84, and then we're going to add 1. 3 times 84 is 252. Then add your 1. So the 84th term in that sequence is 253. All right, you're going to pause the video and you're going to work with a partner on A, B, C, and D. So pause the video and you're going to work with a partner on A, B, C, and D. And then we'll unpause the video and look at E, F, and G. But I will have the answers to A, B, C, and D also posted, okay? Pause the video and try those. Well, I'm going to stop this video because I need to leave. And I'll do a part 2 video where you can pick up with the answers, okay? All right, thank you.